Welcome to the Vielight webinar, Neuro Pro Photobiomodulation, Discovering the Possibilities. Your moderator for today's program is Peter Adams with Vielight.
And welcome. We're really pleased to see the interest in this subject, and this is a very cool start to, I think, a big journey for Vielight and everybody who's involved. So just a little bit of housekeeping before we start. You should see over on the left of your screen, there's a chat button there with a question mark. What we're going to do is we're going to run through the presentations and we'll take questions at the end. We'll see how many questions we get, but if we're not able to answer all your questions and pick them out, please don't be offended. We will definitely commit to get to you one way or the other, so all questions are asked eventually. So about our presenters today, first of all, we're really happy to have our CEO and inventor of the Neuro Pro, Dr. Lu Lim. The Neuro Pro really is a first step in really trying to amp up the discovery speed around photomodulation. As many of you may know, it's really, the whole field has taken off. There are now over 6,000 publications, but we've been, on our side, we've been really limited to looking at direct pulsing, 10 hertz and 40 hertz with our products, and we've seen an enormous amount of success. But Dr. Lu Lim is going to talk a little bit about this particular device and what it represents in the future. And then secondly, we have Penny Jean Gracefire, who Penny Jean is a really well-known educator and innovator in using photobiomodulation in the neurofeedback field. She's a neurofrequency analyst. She's an incredible innovator, and just every day you meet her, there's something new that she's discovered, and she's going to talk us about some really interesting parts of closed-loop feedback that she's already been working on with this device. And then finally, we have Dr. Sanjay Manchanda. Sanjay was originally a professor of electrical engineering and computer science in California, and he left that job to actually pursue study of the mind from a spiritual and mental perspective. And he's also incorporated his skills and knowledge from that field by using and stimulating the brain using various forms of energy, namely magnetic, direct current stimulation, and more recently photobiomodulation. And he has some really interesting early insights using this device in meditation. So without further ado, I'll hand you over to Dr. Lu Lim. Lu, over to you.
Thanks, Peter. My name is Lu Lim, founder and CEO of Vielight. Now, when I thought about what to do with expanding the possibilities of photobiomodulation, one of the principles is going to be illustrated by this very, very short video clip. Can someone play that video? Play. Right, thank you. So what am I trying to say here? The brain has, natural frequencies like a lot of metal and material. Now, you look at EEG, the multiple brainwave patterns that you can extract out. So it's all kind of unscrambled with the EEG software systems. And you decide, okay, alpha looks like that and gamma looks like that and so on. Now, what if actually you can influence it? You can amplify the waveform by introducing a certain frequency. Now we have, we've published, we've talked about 10 hertz and 40 hertz in our devices already. But what if you want to look at what happens with 43 hertz, 57 hertz, So you need to do more than just pressing a button. And that is the opportunity I'm seeing with what we are trying to do by developing this tool that allows you to do it. Now, what if you want to have, you look at the EEG readings, or for whatever reason you find that you need two parts of your brain to have higher connection or coherency. How about looking at a certain frequency? You train it with whatever you think you need to do, and so this tool that we are developing in the Neuro Pro is allowing us to do that. It could be two specific locations. It could be a network basis, or if you want to calm down the coherency, you can also try and do that theoretically by introducing antiphase oscillations. So that is in a nutshell, the idea behind it. So talking about natural frequencies in our brain, Penny Jean is going to show you what. I'm not sure what Penny Jean is going to show today, but I've seen it before when she shows as you do a strip of different frequency, how your brain responds. Now we are done with this debate about whether the brain can respond to photobiomodulation. I think there's enough evidence to show it does. And then talking about meditation, long-term meditators, have developed this, something that makes me envious. I'm not a long-term meditator, but they have developed, I think, a natural frequency much higher than gamma at 40 hertz. You're talking about maybe hundreds of hertz. And it is just latent, is waiting to, for the meditator to get there and amplify it and maybe get into a altered state. Maybe Sanjay can define what this altered state is. It might be like an enlightenment for a while, but it allows you to do that. Now, if we hit that particular frequency and you get that, it just kind of opens up more avenue to what is possible. So the idea about the Neuro Pro is to allow us to explore possibilities. I'm convinced that we are just touching the surface. There's much more to be done. The small group of us is not able to, to discover so much that will, that make life more interesting. So I think this idea about having a community to share experiences will push this path to new discoveries further. That's all I want to say, and I will pass over to the other two speakers.
Thank you, Lou. I guess I'm up first. So I'll begin. I'll introduce the webinar by talking about how I've done some preliminary work in supporting meditation with photobiomodulation. So the basic idea is something that I've been playing with for a while now, 15, 20 years, is to add a small amount of energy, electromagnetic energy, usually, to the system, in this case, the brain. And we use this input of energy to produce a desired state, a state change. And the idea is that as we repeat this application of a small amount of energy to achieve the desired state, as we repeat it, then we can get a desired trait. So we don't have to keep stimulating anymore. So there's various options that we can play with, that we've looked at, that we work with. So on the top left, we have what we're really focusing on today, which is photobiomodulation, application of light, specifically infrared light into the skull. We can use, blinking lights and binaural beats, audio tones. We can use electromagnetic frequencies with coils. We can use DC current with electrodes. We can even use, transcranial ultrasound, which also has electric effects, acousto-electric effects in the brain. And we can use alternating current and so on. So I've played with all of these different modalities, and in particular, we are of course interested in infrared light today. Now, before we go there, we can apply infrared light. We can, do behavior change, yoga, meditation. We can take chemicals to produce the desired state change. Now, having a state change is not the same as learning. So we can have a state change and the system can learn to go into that state on its own, but we can also have negative learning, which is dependency. So when you have chemical dependency, you have the state change, but then the system has negative learning. It gets dependent on the chemicals, for example. What we are finding is that when we use these electromagnetic interventions, there is a large amount of learning and large amount of positive learning, so that you don't need to keep doing the stimulation anymore in many cases. So just a quick review of, when we use photobiomodulation, we are applying infrared light to different tissues actually in the body, in our case, the brain, but it applies to any tissue in the body. And this infrared light affects the respiration chain in the cell. It's absorbed by an enzyme called cytochrome C oxidase, which is part of the respiration cycle, which is part of inside the mitochondria and participates in the respiration cycle. And the infrared light helps it to donate electrons and produce energy and the ATP energy molecule in the cell. In the process, it releases nitric oxide from the cell, which helps to dilate the blood vessels and increase blood flow in the tissue. And also releases reactive oxygen species, which creates beneficial cell signaling. So it has a number of positive effects, the application of infrared light. And in a way, it's acting sort of like food to the system. So in general, we have positive effects on tissues such as repairing, restoring, and enhancing the activity of tissues, reducing inflammation, improving blood flow. So this is just applying infrared light to tissues in the body, which is well researched to have these effects. So I've been using transcranial infrared photobiomodulation, which is basically applying infrared light to the skull. And believe it or not, the skull is pervious to light. It actually gets through and affects the brain positively in the ways that I just mentioned, in terms of repairing, restoring, and enhancing brain function. So ever since Welight came out with the Vielight headsets, for more than a decade, I've been using them in my private practice to help people to recover from brain injuries, to improve brain function, to reduce cognitive decline. So in terms of looking at meditation specifically, we want to affect brain activity. And so we can ask the question, well, how do we affect the brain beyond just the positive effects of applying light? How do we alter the body-mind state with photobiomodulation? So there's, generally energizing effects just by applying light, but can we do better than that? And the idea behind that is that in general, we know how to alter the effects, they have subjective effects on the body and the brain using light. And one way that's been done classically is to use flickering lights in the eyes. So you can, for decades, we have devices that are available that use flickering lights in the eyes, as well as acoustic tones to entrain the EEG. And so then the question we can ask is, what if we flicker the lights in top of the head? Does that have a similar effect? So before we go there, I want to point out how powerful flickering lights can be. So researchers at a lab in MIT were experimenting with mice that were bred to have Alzheimer's. And then they experimented with flickering the lights of these mice cages at different frequencies to see if they had a positive effect on Alzheimer's. And it turns out that 40 hertz in particular has a very positive effect. This is a frequency, a flicker frequency, that decreases plaque in the visual cortex and activates the microglia. So their lab showed that when they flicker the lights at 40 times a second in the rats' cages, that actually has an effect on the EEG. It increases the gamma power. Gamma is 40 hertz range of frequencies and above, and it's well tolerated. And it improved the functioning, the actual cognition and functioning of the rats. It prevented neurodegeneration and reduced plaque buildups. And in fact, the microglia cells are like the garbage collectors in the brain, and they actually start to clear out all kinds of toxins in the brain. So 40 hertz can have many beneficial effects. And so it turns out that when you pulse infrared light into the skull, you get similar effects as to pulsing light into the eyes. So this is a paper by Welight, the people at Welight, who showed that using their pulsed infrared headset at 40 hertz, you got a beneficial increase in different frequencies in the brain, particularly increase in both alpha, beta, and gamma. So you can flicker, say, 40 hertz directly into the skull. You can apply infrared light in the range of 8-10 nanometers. That's what gets through the tissues. There's a whole range of infrared that is used. And you can get effects that are beneficial for cognitive wellness. And the other thing that happens is that if you stack infrared light stimulation with other learning activities, you can get a stacking effect that improves the learning. So studies show that photobiomodulation can increase the speed of learning a new task, as well as the ceiling of learning. In other words, you can learn better, faster when you stack with other interventions. So for example, here's an investigation done at the University of New Mexico that showed that the NeuroGamma headset from Vielight improves learning in a threat detection task. So they're training soldiers to detect threats and say on drone images. And then it was shown in the study that the threat detection can happen faster and better if the students are being trained along with the infrared light being stimmed into the brain at 40 hertz. So of course, what I'm interested in is stacking this photobiomodulation intervention with the activity of meditation. And the idea is that it should accelerate and improve the learning of meditation, as well as we want to look at what different frequencies will do. So that's what we're interested in, is the meditation, not threat detection, quite the opposite. So a number of years ago, Welight created the experimental Neuro Pro for us to play with, that we could stim at different frequencies, not just 40 hertz. Well, 40 hertz has very beneficial effects for cognition, but then the question is, what about other natural frequencies? As Lou was talking about, other natural frequencies in the brain, and how the brain works with them and how we can affect them by stimulating using pulse light. So that's the kind of things we've been playing with for a while. So this is a Neuro Pro headset. We can stim it at different frequencies all the way to almost 10,000 hertz. So as we go into that, let me start by saying a few words about what we know, what little bit we already know about the subjective effects of emphasizing different frequencies in the brain. So we know this from doing biofeedback, EEG feedback, other kinds of entrainment with different devices. So in general, as we increase the frequency of reward or stimulation by emphasizing certain frequencies, as we increase the frequency, the energy level goes up, the body awareness drops, the arousal goes up, and the focus increases, just as a general rule. To clarify that, let's look at this table where we're looking at the emphasis of different frequencies in the brain, all the way from 1 hertz to about 100 hertz. So in the low frequency range, from 1 to 12 cycles a second, as those frequencies are emphasized in the brain, the focus tends to become more internal, the energy level drops, the body awareness increases, the state relaxes, and the emotions are more peaceful or sad. And so this is the low frequency range, also known as delta, theta, and alpha range. And we know, for example, that as we help people to train deeper into theta, they can access past material, old trauma, old feelings that were buried or repressed. It will undo that. It will access body memories. As we move into the more alpha and then into the low beta range, there's more of a balancing effect. The focus is more balanced between the internal and external environment. The energy level is medium, the body awareness is medium, the state is alert and present, and the emotions are more neutral. And then as we go into the higher ranges, from 15 to 100 hertz, particularly the beta range, about 15 to 25 hertz, the focus is more externalized. So when you're in a more engaged, active thinking mode, there's an increase in the power range in your beta range of frequencies. Your focus is more external, the energy level is higher, and the body awareness is low, it's more mental, and the state is more activated, and the emotions can be more agitated or joyful. And the arousal is going up. So if you're starting to look at meditation, you can say, okay, so what is the correlation between meditation and EEG? Now, this is a complicated subject. So for purposes of just this introductory talk, we're going to simplify it somewhat. And we realize that the EEG changes on meditation depend a lot on the type of meditation that's done. And of course, the EEG changes will depend on the location of the measurement of the EEG. But in general, I will say that when you do a focusing meditation, like a mantra meditation, the focusing on the breath meditation, there's increases in the alpha band and the theta band in both power and synchrony across the brain, across several areas of the brain. And in other kinds of meditations, such as open awareness or non-dual objectless meditations, we see an increases in gamma power and synchrony. So gamma power is relatively new to measure in the field. It was hard to measure originally because the amplifier ranges were smaller, and gamma is attenuated by the skull. It passes the low frequencies but tends to attenuate the high frequencies that are produced by the brain. However, there's many intriguing results on how gamma power is significant for meditators, as well as high-functioning people such as musicians and mathematicians, who have been shown to have on average, higher gamma power than other people, than controls. So this is a paper that shows that the measurements showed that the gamma range of frequencies from 40 hertz upwards to 100, 200 hertz the meditators had higher power in the gamma range compared to control in 3 different meditation traditions. So that made us interested in seeing what if we stimulate the gamma range of EEG in the brain, and is that going to help with meditation? We know that the brain produces high frequencies in the very high range, and this can be seen in cortical recordings. So when there's brain surgery going on for any reason, and we place electrodes right on the cortex, then we can measure high frequencies that the brain is producing that are not filtered because of the skull, so that we can measure them. Now, we also have other intriguing results, such as the ingestion of psychedelics that has been shown to be associated with higher gamma power and synchronization. So in general, if you look at the research in EEG and meditation and my experience in this field, so earlier we had papers on meditation that would all point to how meditation increases delta, theta, and alpha. And now we're starting to see results on how meditation increases gamma. And if you look at the subjective correlates of these frequencies, emphasis, then one way to think about it is that we can think of frequency as an index to different states of awareness or experience of oneself. If we emphasize the lower range particularly, then we start to get an emphasis on the body, on instinctual functioning, on access to unconscious and pre-personal and pre-rational material, more of the emotional aspects. And in fact, also psychic and mediumistic functioning. I have a friend who's a very effective medium, and he's also into EEG. And occasionally he would, a few times he sat in on some of my sessions that, with permission, with clients that I was working with. And when he focused on those clients, I would see a huge bump in delta in specific areas of the client's brain, very predictably. And he told me how his own brain EEG shows an increase in delta, particularly in the parietal regions, that he associated with his mediumistic abilities. So there's something about these frequency ranges that are connecting at a very earth plane level, especially the low frequencies. Now, if you look at our usual functioning in the range of, in the low beta ranges, that's where we usually, that's kind of functioning emphasizes those ranges, and it's a usual functioning of a mental functioning, intellectual, usual conscious mind functioning in society. And so by definition, what we call altered states are states in which we are moving out of this narrow range between these bars into, more low frequency states or high frequency states, or some combination of the two, actually. And as we emphasize the high frequency amplitudes, we start to find that we have more access to the superconscious realms, feelings of expansion, transpersonal energies, a sense of being post-rational, beyond the mind, and spirit and intuition. So that's like a simple way of tracking how emphasis in different frequencies correlate with subjective experience. So the Neuro Pro is, in a way, ideal for high-frequency stimulation, and it works better than, say, doing neurofeedback because it's so difficult to measure very high frequencies accurately and then to do biofeedback on them, to train them in the brain. With the Neuro Pro, we can just stimulate by blinking the LEDs at a high frequency and hopefully get strong physiological and body-mind effects. And we find that it's indeed the case. How much and how well, we're still studying it. So in preliminary work with long-term meditators, we found that high-frequency stimulation resulted in reports of increased self-observation, increased equanimity, more positive feelings of joy, expansion, and we tried different frequencies. We picked frequencies of YouTube. What is the solfeggio scale? Let's try this, and or maybe more physiologically relevant frequencies to see what we can do, what kind of body-mind states we can produce. And we use long-term meditators because they're good reporters. They have access to, what's going on in the body and the mind, and we can start to get reports quickly. So we get some interesting results with high-frequency stimulation, many positive states showing up, but also negative states showing up, states such as agitation, dissociation, discomfort, or sleep issues. In general, the brain, is producing all frequencies at all times. We are just emphasizing certain frequencies. But specifically, the brain uses the phenomena called cross-frequency coupling, where the high frequencies, gamma frequencies, are phase locked typically, or otherwise time locked to low frequencies. So this is a diagram of a theta gamma coupling in the hippocampus of a rat. And this kind of coupling where you see the high frequency vibrating on top of of a low frequency as a carrier wave, and is being used in the brain to time the access of different memory components in different parts of the brain. And the gamma refers more to is associated more with the actual content retrieval, while the theta is more the timing, accessing the timing. So this is similar to how radio programs are broadcast on top of very long radio waves. So they're more like a variation within these long waves that will carry the radio program, and then the content is programmed on top of it as a carrier. That's using that as a carrier. So the idea here is that we don't just stimulate low frequencies or high frequencies, but both in some way. And so we can, with a device as versatile as a Neuro Pro, we can really have a lot of different experimentation by doing both in sequence or simultaneously, in phase or out of phase, and in different parts of the brain. A subjective correlate of looking at how we want to work with both low and high frequency is to think of a meditation as a balance between opposing factors. So we can think of mindfulness itself as a factor that's a balance between other factors in a subjective state when we're meditating. So when we meditate, we want to be in a calm and tranquil state. But if you just focus on calmness and tranquility, you're going to fall asleep or get what is called sinking mind. So in a beneficial meditation state, you have to balance that with a sense of energy and a sense of being active. So there's a balanced state has energy as well as calmness. And they're opposing factors that are balancing each other. As you start to meditate, you start to get positive feelings show up. Joy shows up, a sense of pleasure and bliss in the body typically arises. And that is balanced by a sense of being very neutral, equanimity. So you're not attaching or really going into it and getting highly caught up in those feelings. As you balance, as you bring equanimity to bear on the feelings of bliss, you achieve a very balanced state. And they're kind of opposing factors. Similarly, when you increase concentration by repeatedly focusing on a particular object, then that's not the end all be all of meditation. You actually want to use that concentration like a lens to investigate the nature of your experience. And that investigation is actually disturbing to the mind. So you balance the concentration and the investigation aspects. And so this actually list of 6 factors that make up the 7th mindfulness are called the 7 factors of enlightenment in Buddhism. So the reason I brought this up is to talk about how there's these different aspects of a meditation state and how they might correlate with different aspects of the EEG. So the question we've asked ourselves is, can we have a balanced mind protocol in which we can create a high functioning mind with high mindfulness that helps us to release the grip of the narrative self? And we find that we can start to do that by combining different combinations. So originally we were working with just sequencing different frequencies. So you combine stimulation at delta, theta, and gamma frequencies. So we're moving outside the usual alpha, low beta, beta range, and we stimulate the low ranges and the high ranges. So that's the altered state, moving out of a usual state, so we're more altered, and stimulating both the low and the high. And so here we are doing this at one of the Science of Consciousness conferences with Chuladasa, a meditation teacher, and often long-term meditators will report different states of opening, like expansion, lightness, increased perceptual clarity, peace, joy, energy, and reduction in thinking. So the basic idea here is in using a device such as the Neuro Pro at different frequency combinations to increase the depth the breadth and the flexibility of access to different mind states. So we should be able to deepen certain states associated with certain frequency signatures, increase the breadth, so be able to access states that we couldn't access earlier, and to improve the flexibility of moving across states, because different states can help us to function in different ways. And we don't necessarily need to be stuck in those either. We also discovered that as through time, these things can be individualized. So most meditators preferred certain frequencies within the tested range, and these frequencies help them to gain optimum access to a deep state where they could work and deepen further. So different people were, in a way, working at different levels. Some people preferred certain higher frequencies, and some other people preferred lower frequencies. In a way, it took them to their edge, to where they were working already in their meditation practice quickly, and then they could use the frequency stimulation to go further. So to show that indeed this is doing something, and to correlate the effects of the stimulation with subjective experience in EEG, we initiated a study with long-term meditators. And the idea of using long-term meditators is that we only need a few sessions with them to start to get, because they can good reporters, and we can start to see what it's doing. And so in this study, we have 6 sessions. We have baseline sessions. We have active and sham active sessions, and pre and post EEG recordings. And we take meditation, mood, and sleep measures. And this is being conducted at the University of Arizona at the SEMA lab with Jay Sanguinetti and Shinzen Yang. And we just currently shifted the study over to the U of A, and then the process of structuring it, making it happen. So it'll have 2 parts. So the first part, we're going to stimulate with a whole range of frequencies, and take measures, including the mystical experience questionnaire. And the idea is to just show that the stimulation indeed creates altered states and helps meditators to deepen. And in the other part, we're going to try to create a more individualized optimum frequency selection and see what that does for specific meditators. All right. That's what I have today to say about it so far, and we can continue the discussion.
Sanjay, Dr. Manchanda, thank you so much for that. That was truly, it's truly groundbreaking to see some of this stuff quantified. It was very interesting. So now we're going to move on to Penny Jean Gracefire, and very excited to find out what's happening in her world, which is constantly changing and evolving. Penny Jean, welcome.
Thank you. Can everybody see my screen? Is the sharing option working? Okay, did I not take myself off mute? Can you hear me okay?
Yeah, you're good.
Okay, wonderful. And can you currently see my slides?
We can.
Beautiful. Okay, Sanjay, thank you so much for that excellent overview. It's really perfectly set up a handful of the things that I wanted to talk about today. And the main thrust of what I'm interested in doing is trying to put together a little bit of a framework for how you can think about utilizing some of the new features available to us now in photobiomodulation that have never been available before. And let me start out by telling you that some years ago, when I first met Lou at a brain conference, we ended up in that liminal post-conference airport hangout space, right? Waiting for our flights. And we were chatting, and I said, Lou, I really am impressed with the devices that you have and what you've got going on. I said, but they currently only allow you to pulse at 10 hertz or 40 hertz. And I really would like more options. And in one of the greatest moments of instant gratification in my life, Lou pulls out what was a prototype of the current Neuro Pro and says, oh, like this? and shows me, essentially what he was working on at the time. And after some years of development, a lot of teamwork from a lot of people, I finally got my hands on a Neuro Pro last year, and I have been doing a lot of very fun things with it. And so what I want to do is just talk about how having some experience with EEG and having some experience with neurofeedback and just thinking about things in terms of how we understand brain dynamics can really help us think through utilizing and really getting the most out of the what are currently features that have actually never been available before in photobiomodulation. Okay, so first things first, understanding your equipment, understanding your options and features is what's going to help you create your own framework for deciding what it is you want to use it for and how you want to apply it. So currently, since we're discussing the Neuro Pro, let's just do a quick breakdown of what it actually has, what it does, what some of the features are, and then think through how we can potentially apply that to either consecutively or concurrently or adjunctively using the photobiomodulation options integrated with EEG. Okay, so right out the gate, there is a nasal cannula or a nasal applicator. And there's also another independent little diode that you can actually set up. You can see the pads available so that when you actually put it on your head, you can put the thing anywhere. But for purposes of discussion and just for thinking about sort of neurodynamics, the most common way I've been using it is based at the base of the skull, really kind of near the cerebellum. So thinking in terms of how do we access the bottom of the frontal cortex, and one of the sort of most effective ways to do that is through this nasal application. And how do we access the back of that cortical loop, right? That's going to be potentially with this independent diode. So we already have, even just with these two, we've got a really nice kind of basal cortical anterior cingulate, potentially to cerebellar brainstem activity loop going on. But we can add on top of that, because what essentially the Neuro Pro comes with is a nasal applicator, the sort of independent diode you can put anywhere, but I'm primarily using on the cerebellum, and then a headset that has 6 additional LED diodes. And so when you think about sort of, you can use these independently and you can layer them all together. And so, for example, if I have the headset on and I add in the independent X module, now I've got headset and I've got potential application back to the cerebellum area. And then I can also layer in the nasal applicator on top of it. Now we've got 8 diodes total that I'm working with, right? This is a lot of coverage. And not only is a lot of coverage, it's actually a lot of selections and options, because the nasal cannula, the independent sort of X module diode, and then the 6 individual LEDs on the headset, all of these can be selected and programmed to do either independent or synchronous activity. The reason I'm including some of these visuals is to help us just think through, okay, if we understand what the capabilities are, we can match those up with what we already know and understand about EEG dynamics, what we've already learned through some years of doing potentially either neurofeedback or EEG biofeedback. We can correlate those together, and then we can come up with ways of putting together strategies for design and use and application. Okay, so a couple principles about thinking through, if we can look at EEG dynamics, what are the primary things that we often try to conceptualize or use when we're doing neurofeedback? All right, mainly in neurofeedback land or EEG biofeedback land, we talk in terms of power and connectivity. So the idea of being able to put electrodes at a location, measure how much activity is occurring there, and then potentially give feedback based on increases or decreases in local regional power recruitment, but also the idea of networking and how different areas network together and provide more complex information. And so when you think in terms of EEG frequencies, one of the ways that helps me to conceptualize it is to think of it in terms of tasking states. Faster and slower frequencies have different jobs that they're essentially in charge of. And so as your brain is moving between, different degrees of frequency activity, you're essentially focusing on or spending more time in different tasking states. So when this is why I really have appreciated so much Sanjay's presentation, is because he's really sort of grounding what I'm discussing in a little bit of an abstract way. It's a very practical application. And so when we're thinking through, okay, we've got these different tasking states, faster and slower frequency bands that we tend to hang out in, how do we conceptualize that in terms of what is the EEG doing? What is the brain doing? How is that relevant to function? And how is that relevant to how we pick or select out the different ways that we can introduce photobiomodulation into those circuits? And so if you think of power, the power metrics more in terms of what do you have kind of going on locally and regionally? How are you recruiting and prioritizing resources? Like, what is the hierarchy for which regions or locations in your brain really have access to more sort of consistent resourcing capabilities? And then you think of the connectivity metrics in terms of how do we network things together? How do we make decisions about what local regions get essentially coupled up together to do more complex processing and tasking? Then we have sort of a framework for how to think through selecting areas and metrics to base biofeedback on, right? But what if we start introducing additional photobiomodulation or additional stim on top of that? Okay, are you ready to find out what this thing can do? So one of the things that I really, really enjoyed about getting my hands on sort of the early modules was just being able to think through all of the different potential ways that we could ask the brain to pay attention to the information we're trying to give it. So when you have more choices and more options, as our EEG biometric capability for observation and measurement has improved and become more complex and more sophisticated over the last 10, 15 years, as our technology has allowed for us to see more complex, sophisticated, dynamic interaction in the brain, our ability to give the brain information has also become more sophisticated. So when I say there are features available in the Neuro Pro that really haven't been available before, my excitement is around this idea of what do I get to tell the brain? What do I get to ask the brain to pay attention to? And what level of conversation can we have in a feedback loop, even if it's just a feed forward, like let me just put some stim on you? The level of complexity and sophistication of the types of STEM experiences we can design is currently unprecedented. And so, for example, when we're thinking through how do I want to select out which frequencies, you have the ability to select out individual, like each of those. So we've got our sort of 6 diodes in the headset, right? And then we've got our X module and our nasal app. You can select out frequencies for each of those individually. What sort of pulse rate would you like for them to be pulsing activity at? And so you'll notice this little note here, upper frequency limit is 10,000 hertz. I'm going to have some comments on selecting ranges here in a minute, but you can see that they've essentially given you a Ferrari, Porsche, Lotus level machine here with how much capability it has available. So what we need now is just a framework for how and why we select different things. Another thing to consider too is the idea of a frequency sweep, right? So when we are identifying, when we're thinking through how does the brain actually work and how are we trying to ask it to pay attention to us, one of the things we can do is select out specific frequencies and just kind of hang there, create some resonant experiences, say, oh, give us a lot of 40 hertz resonance here, give us more alpha, we can ask for sort of consistent, sort of localized or focalized frequency behavioral resonance, right? Or we can do things where we kind of, to a degree, model increases and decreases or shifting between the different tasking states. So you can design sweeps where you start in a frequency range, you increase up into faster frequencies, and you potentially can come back down into slower frequencies. You can decide how quickly you wish to stair step up, essentially how big your steps are going to be. So you can say, oh, I want to jump 5 hertz at a time, or you can say, no, I want to go one frequency, a very sort of sensitive stair step up or down. But what you can do is you can ask the brain to increase or decrease frequency sweep speed. And one of the advantages of this is essentially this idea of designing an experience for the brain to have over time. So sitting there and just sort of getting stemmed with 10 hertz is a valuable experience, but it's a different one than saying, hey, let's start out in 10 hertz, and then let's maybe take you up into some of these higher frequency ranges. And sometimes when you leave people in the higher, faster frequency ranges, there's a little bit more activation than maybe everybody has the ability to sort of consolidate themselves to sort of recalibrate afterwards, right? Where Sanjay was talking about people who are more experienced meditators and have more experience in kind of regulating out their states. Well, our ability to kind of take them up into faster states, but then to potentially bring them back down and end maybe in a sort of an alpha or a mid-range frequency band means that we can actually help them sort of come down from that higher experience as well and leave them in something that's a little bit more moderate. So for people who might have difficulty post higher frequency stems, like this is such an excellent option to help them experience that as well. And so when we're thinking through, like, how does introducing the stem activity, like independently or coupling it up with EEG feedback, you have options everywhere from, do I want to do a little priming stem and then do some various neurofeedback protocol designs, or do I want to couple them together and do them concurrently? Or do I want to potentially loop them together and do a closed loop experience where the feedback, the actual photobiomodulation becomes part of the feedback? And all these options are currently available in ways that they haven't been prior to the last year or two. So essentially this idea of how does the brain respond when I combine things, I have really found that, using photobiomodulation and neurofeedback or biofeedback in the same session allows for both a priming effect and just more sort of contextual sophistication for how the brain can understand making recruitment choices in local power dynamics and also making choices across more complex global networking strategies. And so this also leads me to making decisions about how much power are we asking each of the diodes to stem at. You would also select how strong or how gentle you would like for the power to pulse at, and being able to select out, both like independently how strong you want each diode to pulse at, and also being able to essentially do a power sweep where you start off a little gently, maybe get a little bit more intense as the session goes on, or like I was saying before, start off a little gently, get a little bit more intense, and maybe kind of fade out towards the end. You really have a lot of options for how you can design that experience, right? And seeing the types of shifts in power dynamics, like for example, this is an absolute power 1 hertz bin, sort of a, let's say this is a quantitative analysis of how diffuse behavioral sets in power between 21 hertz and 40 hertz. So these are some faster sort of beta edging up into the bottom of gamma frequencies. These are shifts in power recruitment and activation after a single session and then potentially after a few more sessions. And I'm kind of showing you these as examples to help to illustrate, like conceptually, what is happening when we're selecting out these different options. And I also really appreciate the concept of being able to design out, like, when do I want certain frequency bands or certain experiences to start in the middle of that arc or that design journey for the brain, right? So the active time or sort of the time delay for the session design, you also have these options where you can say, okay, I would like 4, and this is, I love this element. I would love to start with just maybe just maybe that module, the X module back at the cerebellum, maybe I'd like to start with a few minutes of just doing a little alpha there. Then maybe I'd like for that nasal applicator to come in, a few minutes of those together. And then maybe I would like for the rear set that I've possibly adjusted over the parietal cortex, maybe I would like for those to start creating a little bit of alpha and then speeding up into some of the betas for more integration. Then maybe I would like for the frontal. And what you can do is you can literally create sort of these sequences where you're essentially imitating the way the brain naturally increases or decreases frequency recruitment bottom up, right? From lower brain to cortical to higher cortical regions. And so you can also have those sort of complex conversations that way. And then the kind of one of the really exciting things, and this is just, it's new, it's different, and it's so relevant. This idea of being able to select out sort of a phase synchrony or asynchrony experience. You can select any of those 8 LEDs and combine them into sort of this phase offset option, where essentially you can say, which one of these would I like to be in phase A, and which one of these would I like to be in phase B, so that anything that's in A is going to synchronously pulse together. Anything in B in the secondary option is going to pulse offset from the first option. And the reason why this is so interesting and critical is because you can actually design out various different ways to impact how global connectivity and networking is occurring. Because when we talk about, phase lag or coherence, or what are the behaviors between local regions, how are they connecting together, exchanging information, and how is that sort of cross-frequency coupling happening, right? You can actually select out specific frequency bands you want them to pulse at, and then specific, essentially offset frequencies or offset locations. So I can say, oh, I would like for the front to pulse offset from the parietal. I would like for all the diodes I have on the left side, I would to pulse different from all the diodes I have on the right side. So you can do intrahemispheric, interhemispheric, front, back. You can do diagonally. You can literally pick any combination that you really want here. And so I know for some people, options equate to anxiety. And for some people, options equate to freedom, but in potential. And so for people who are saying, well, this is really fascinating, but okay, do I really need to do fancy things to get good effects? Great question. The answer is everything you do is going to have effects. And here's a couple of little pre-post images where I literally just stemmed some sort of consistent alpha using only the nasal cannula and using only the sort of the X module placed at the cerebellum or sort of the base of the skull, right? So I had that nice little bottom of the brain sort of, cingulate kind of a low connection, like front to back. But if you will look at these images, these are more sort of the three-dimensional S Loretta, so you can see kind of deeper in the brain some of those changes. This was prior to doing any stem. This was my baseline. After I did about this was a 20-minute stem of 10 hertz, just the nasal and the cerebellum, right? 15 minutes after that stem, so I stemmed for 20 minutes. I waited 15 minutes. I did another collection. I waited 30 minutes after, I did another collection, and I waited an hour after, and I did another collection. And you can see, just to sort of contextualize, this sort of diffuse theta activity was hanging about maybe, a little, almost 3 standard deviations of activity in theta. You'll notice that, immediately post the stem, there was a significant jump in that theta activity, right? And about half an hour later, it starts to kind of come down a little bit. And then roughly an hour later, I have the theta frequency has reorganized and is hanging out a little bit closer to standard deviations. But this is like a pretty significant behavioral shift. And I love that Sanjay was talking about the theta gamma, because this is same brain, same pre-post. This is the behavior in gamma. So this is my stem, the baseline prior to any stem. You'll notice that we're hanging a little over 3 standard deviations of gamma activity. This is 15 minutes post-stem. Remember, nasal and cerebellum just 10 hertz. This is, you'll notice that we started off about maybe 3.3 standard deviations of activity. We kind of come down to maybe 2.7, kind of come down to about 2.6 a half an hour later. By the time we're an hour later, we're about a standard deviation down, which is a very interesting shift. But there's something I want to point out. Do you notice in the baseline, before any stem, see this tiny little blue spot? Let's just take a quicker peek at that. And then I'll pause and kind of see where we are with time and questions. Okay, so this is a little bit of an overview, right? It's kind of what's the average activity between 35 and 45 hertz, trying to kind of understand, right? But if we were to break it out into individual frequency bands, like this is 39 hertz and 40 hertz, right? So prior to any stem, this was sort of the lower recruitment, sort of this is how low the activity was in 39 and 40 hertz. This is 15 minutes post, 30 minutes post, and an hour post stem. This is a significant change in recruitment in 39 and 40 hertz. This is 42 and 43 hertz prior to any stem. This is at 15, 30 minutes, and an hour post. Again, this is an alpha. This is a 10 hertz stem. I'm not even doing anything fancy. I've literally just put that little nasal cannula and I've put the little X diode at the back. I've just stemmed for 20 minutes in alpha, and look at these shifts in even the gamma activity. This is 44 hertz and 45 hertz. And this is 15 minutes after the stem, 30 minutes, and an hour later. These are significant kind of deep shifts, even just with the nasal and the occipital. So, I mean, obviously I've been seeing some really kind of impressive and fancy complex changes based on doing more sort of sophisticated designs with the capabilities, but even very simple introduction of photobiomodulation, especially if you can give it a little bit of a network capability, right? Just for fun, I'll show you like a couple little things, but the reason I'm talking about this in terms of sort of placing things at maybe the bottom of the anterior cingulate, bottom of the anterior frontal cortex and back of the cerebellum, there's so much happening in these loops between sort of subcortical and cortical activation. There was just so much happening that we are able to a degree, access where we were doing neurofeedback. When we do EEG biofeedback, we primarily are thinking through pyramidal sort of cortical activity and how we can access that. And our ways of trying to get to some of those lower activity loops has really been through sort of associative circuits, like what do we have in the cortex that we can get a hold of and change the behavior and sort of get to some of the subcortical regions. But when you sort of layer STEM on top of that, your ability to maybe recruit activity in behavior in some of those lower regions actually becomes much more enhanced. And there are so many sort of lower cortical loops up into the cortex that we can like almost target with more sophistication, right, with the STEM. And this was, for an example to sort of talk about it. But as I was looking at these, I was saying, sometimes when we look through these more complex regional descriptions of how those loops work, this was a little bit me sort of almost having a joke with myself, but also, so I put this in, right? So what even is a mediodorsal nucleus? Like, what does it do? Part of the reason I even included this little sort of caption is because sometimes we don't think about how all those little sort of subcortical regions actually play such relevant and crucial roles in what we're thinking of as maybe higher level executive function behaviors, right? You actually need a lot of those subcortical circuits to be activated, engaged, and sort of looped into even what we're thinking in terms of sort of all that global networking and higher cortical function. So, being able to potentially impact and recruit, even just to enhance some activity as we're doing EEG biofeedback, even just being able to prime some activity prior to doing neurofeedback, like these are really like obviously you can see how excited I'm getting. I'm making a lot of gamma as usual, but you can see like there's so many ways that we can use this for both clinical application considerations, but also just the concept of exploration. We're able to do more sophisticated photobiomodulation. We're able to do more sort of more sophisticated EEG monitoring and analysis of how those brains are changing as we're introducing different things into the sort of the ecosphere of the EEG, right? And the being able to watch the changes in the economics of how we're recruiting resources and sort of distributing them across the cortex and between those cortical and subcortical circuits. I mean, this is an entirely new frontier. Okay, I'm going to pause. I've gone a couple minutes over our designated time. Let me check in.
Thanks both. Thank you, Penny Jean, very, very much. Thank you both for almost defining the universe in 20 minutes. This is like flying a 747. So very much appreciated. I tried to answer, both Austin and I tried to answer a lot of questions online, but there was one or two questions that I think were for Penny Jean, and I'm sorry, Francois Altweis and Jan Kotowski seemed to chime in on how and which 11 frequencies were given, or how do you define optimal frequency? And I think they're for you, but I'll give them to both of you if you want to.
Yeah, no, I think they refer to when I said that in my study I was doing 11 frequencies. And, we'll have to look at the study to see what they exactly were, but they're in the range of, that's an issue. There's so many possibilities. And I picked certain ones that I thought I wanted to explore. And so the basic idea wasn't just to get the right 11 frequencies, but to go across a range of low to high to see what that does, because we are still discovering what specific frequencies do. So certainly that range included things like 2, 5, 10, 40, 80, 120, 432, and 1024. So there were certain frequencies that we are finding are quite relevant to meditation, like 120, which is, a new thing that I'm discovering. But so that's the 11 frequency include the frequencies I just mentioned. But it's by no means like a list that is very, very clear that I know I should be using exactly those. Mm-hmm. But I wanted to cover a range from low to high and allow people to have this sort of sweep that Penny Jean was talking about, also have a sweep mm-hmm. effect. And we find that has some interesting results of people doing that. Yeah. And then the optimum frequency was defined by the individual. So we will go through a range of frequencies, and then the individual will report their experience and ask them questions after each stim for 2 minutes. And then the individual will report their experience and see what they experienced and what they liked, literally. So the optimum was defined by their subjective experience and what they preferred. That's how we decided an optimal frequency. It's different for each person.
Great. Thanks very much, Sanjay. So there's another question here. Do you think any long-term meditators think this device should be used cautiously for non-meditators? Do you foresee any potential pitfalls using this in meditation?
I guess we can both answer that. I think that there can be a lot of high frequency stimulation will specifically can produce dissociation, agitation. A lot of low frequency stimulation can bring up more emotions and personal material. When we are helping people to enter altered states, that has certain consequences, which anybody familiar with altered state kind of work will realize is that, you can have experiences come up that were repressed or subconscious, or, with a lot of arousal, you can have difficulties with arousal. For example, if people have bipolar disorder, a lot of activity, arousal activities would not be beneficial for them. If there's a lot of repressed material, a lot of low frequency stimulation can bring up repressed material. So ideally, so these are some of the things to be aware of. These are not like medically dangerous things, but we are altering people's state of mind. And so if somebody has a more unstable history of not being able to regulate their states, doing this by themselves would be less safe. and should be done in a therapeutic context. That's what I would say overall.
Those are
Yeah, but I don't see it as extremely dangerous. But this is what to be aware of. Yes. Yes.
Thank you.
Penny.
Thank you.
Yeah.
So
Penny Jean,
we have.
No, I want Penny Jean to say something about it.
Oh, sorry, Penny Jean, go ahead.
No worries, no worries. I was just sort of to add to that, which were great comments. One of the reasons that I've been so excited about pairing this with EEG biofeedback in general, or neurofeedback, is that when you introduce STEM into a system, any type of STEM really, like all the things that Sanjay was describing in his presentation, including photobiomodulation, when you introduce STEM into a system, you're essentially asking for that system to process the information that you've given it. And systems that are fairly well organized and not too compromised honestly get a lot of benefit out of various different types of STEM. But when you've got a system that's pretty compromised, either through illness or injury or arousal, regulatory difficulties, all of that, sometimes there's more difficulty for organization and sort of integration of the STEM and information that you're giving it. So people who do have a lot of like physiological or psychological compromises, they often benefit, like you said, from more supervised STEM environments, but also I've noticed that there tends to be a lot of benefit when you are able to combine the biofeedback or the neurofeedback with the STEM. So either doing your STEM and then a little bit of neurofeedback to kind of help with the integration, right? And then, or potentially doing it even in a closed loop where you've got the bumpers of the sort of the expected ranges and feedback of the, of the EEG biometrics layered through the STEM. So you're almost like guiding them in real time how to sort of integrate in that photobiomodulation information. So they're a very excellent pairing. And one of the ways to modulate those concerns is to think through, how do we give them some bumpers as that brain, how do we give the brain some guidance as it's trying to incorporate, integrate, and do something useful with the photobiomodulation information.
Good. Thank you.
Thank you, Sanjay.
So we had a few other questions. Actually, one very simple question. Somebody has commented, Cheryl Monahan commented, will we have access to the webinar afterwards? Yes, everybody will. It sounds like people got a lot of really good information across today. Another question came in, is there any therapeutic or medical research ongoing with this instrument? And as we measured, this is a brand new instrument. So all of the research we've done thus far has been with products called the Neuro Alpha and the Neuro Gamma. And you can find that information. I put that up there at research.vielight.com. So you can see everything that's going on there. There's one piece that probably isn't going on. We've just completed a COVID-19 trial using the Vielight X Plus. And the results, exciting results, will be published coming out of that very, very soon within the next couple of months. Lou, if you want to comment, fine, but I think that just about covers it.
Very, very briefly, I'm actually preparing the first draft of the manuscript. It's doing something. It is actually accelerating recovery from COVID-19. At the time when we did the trial, the Delta variant was prevalent. So those who have presented symptoms up to 7 days, the change is significant. But anyway, we are very soon, in a matter of days, we're going to be submitting for regulatory approval and probably submission to a high-impact journal. So we'll see what happens. So that is the X Plus, already available. When I first designed it, you look at a user guide, there's one for the head, one for the body. All I said about the body was place it here. We didn't say what it's for because we couldn't say anything other than making you feel better. But I think now the clinical trial data is coming out is quite interesting. So it's helping your head is photobiomodulation literature shows that it does a lot of stuff just because fundamentally it acts on the mitochondria, which is everywhere. It affects virtually every function of your body. If you can deliver in the right places with the right dose, you can have an effect. Just do it properly and not overdo it. So we'll see what happens after this.
Thanks, Lou. So we had another question. Will there be a discussion group or presets for beneficial stacks and configurations to optimize use of specific conditions? For example, amygdala. Oh, Rico Petrini just asked that question. Thank you, Rico. Yeah, and suspected CTE. I guess I just received a text from the University of Utah where we completed a study which is now going to be published in public at the Sports Psychology Symposium next month. So stay tuned for that. But the answer to that question, Rico, is yes. There are discussion groups. We'll publish how you join those groups if you have the Neuro Pro. Initially, the discussion groups will be for Neuro Pro users to basically share insights. But as time goes on, we'll share the information far and wide as to what to do. But certainly, if you're a user, you're going to have an inside track on the latest research that's coming in. And I think that's about all we have time for right now. This has been a really good discussion for nearly 100 people here, and we're really grateful for you all participating. So going forward, please feel free to reach out. All of the questions that you've published here, if there's any we missed, we will get back to you. And I would also encourage you all just to go to pro.vielight.com. Keep going there, and you're going to see as things evolve, there's a whole rollout of very exciting new associated products that will come from the Neuro Pro side. And I'd just like to thank Sanjay and Penny Jean one more time for helping us here. This has been a really great session. Thanks all very much. Thank you.
Thank you.